I started working on chilies by working with Gary Nabhan, and Gary's an ethnobotanist, and we started out having chili eating contests, and then realized that we had a love for the science of chilies as well as for the exposure to chilies. We are the only mammals to eat chilies willingly. Well, okay, goats will eat chilies willingly. Hi, my name is Josh Tewksbury, and I'm a professor in the Department of Biology and the College of the Environment, trying to figure out why chilies are hot. I'm deeply interested in understanding the significance of that spicy chemical we take for granted in the plant that produces it. I want to go back to Bolivia. I want to go back to the center of biodiversity for chilies, for wild chilies. And I want to understand how it is that chilies became hot in the first place. We think, why are chilies hot? Well, we know something about that. We've been studying this for a while. We know that at least in a couple of species, the primary way in which chili seeds die is they get killed by fungus. Most of the fungicides you see in the world, agricultural or household, are based on a very simple principle. That's a chemical that kills fungus and doesn't kill us. That's what I think chilies have evolved naturally. I was able to work with a team to figure out that it turns out that this property called the heat principle in chilies, capsaicinoids, is in dramatic flux. When you can find a collision between your gustatory passions and your intellectual passions, why would anyone say no to that research project? One of the most remote locations in the New World that we work in, we take 3 spare tires and an extra 50 liters of gasoline everywhere we go because we're constantly blowing tires. It's really an expedition. But we can stay in touch pretty easily with satellite phones, and we can stay in touch pretty easily with blog updates. And about right in there, new species of chili discovered just 3 years ago. This was picked up 50 years ago, misidentified, stuck in a drawer. We need to go back and find the type specimen. This area down in here, all this zone, everything we find in there, you'll have a hot one sitting right next to it, a not hot chili. You can't tell them apart except by eating the fruit. And so this pattern has this really cool gradient where most of the plants aren't hot at all over here. Most of them up here, a little higher, a little wetter, are all hot. More fungi here, more bugs attacking the seeds here, drier here. These are the selective gradients that I think really have a lot to do with determining when it's better to have chemical protection and when it's better not to. Literally what we've been doing is going into the field and eating chilies. And this seems like fun if you're a chili eater, but after you eat 50 or 100, it's not. But this is how you figure out where the pungency is. Of course, we take them back to the lab and we use an HPLC to figure out exactly how pungent they are. We do the right science, and it also allows me to connect with something I feel passionate about, which is working with and bringing science into developing countries and working with graduate students and undergrads in those developing countries to create greater appreciation for the natural world that's around them. We have a network of collaborators in Bolivia. We've already trained grad students from there, undergrad students from there. There's an exchange program we've worked on. We're working with the Natural Museum. We will put plant specimens in museums, but we will also take digital photographs of everything we do. We will upload all those. We start working by putting everything online. Our notes, our updates, our photos, our logs, our blogs. This is how science will be done in the future. We won't be hiding it in our notebook and then publishing one paper that experts can read. We will be sharing our stories because something as basic as why chilies are hot could help us develop better fungicides, could help us develop better treatments. We believe in this process of doing this in the field and understanding the functional significance of chemistry. There is no better system than chilies to do this in because we're so passionate as a society about chilies. We know so much less than we think we do. And with a little bit of effort, we can know so much more about this amazing evolutionary story that links to our own history, to our patterns of taste and our patterns of culture, and ultimately to the way in which we conduct our own fights with natural pathogens.